This is problem 11 from section 6.1. If a rancher uses a river bank to border one side of a pasture as shown, he can enclose 11,700 square yards with 310 yards of fence. What will the dimensions of the pasture be then? Okay, so let's label the diagram. We're going to have the length. We'll just make that the longest side of the rectangle, and then the width. And notice altogether we have just one side of L that needs to be fenced and two sides of length W. Okay, so we're going to start by filling in the table. If we're given a width of 50 and the corresponding length of 210, we can find the area by multiplying the length and the width together. So we get 10,500. Okay, given a width of 60 and length of 190, the area is 11,400. And lastly, width of 80 and a length of 150 produces an area of 12,000. Well, let's think about how we could get the length if we only knew the width, okay, and recognizing that there's 310 yards of fencing. So if we add one length plus two widths together, L plus 2W, we should get a total of 310 yards. If we take 310 and subtract 2 times the width from it, we would get the necessary length. Okay, so let's try one of these out. If the width is 50, so the length is 310 minus 2 times 50, and that gives us 310 minus 100, or 210 for the length. In part B, we want to write an expression for the length L of the pasture if its width is X. Okay, so pretty much we wrote this formula just a second ago. However, we're going to use X instead of W, so L equals 310 minus 2X. And then we want to write an expression for the area A of the pasture if its width is X. Okay, so for a rectangle, area equals length times width, and we're going to make some substitutions into this equation. So instead of L, we'll put 310 minus 2X, and instead of the width, we'll put X. And distribute, we get 310x minus 2x squared, a quadratic function. And lastly, we want to graph the equation of the area. So area as a function of the width, x, and to do that, we've been given a hint that the x-coordinate of the vertex is 77.5, and so I would substitute 77.5 for x and evaluate, and that gives me this y value of 12,012.5. And so I'm going to approximate where that is on my graph, and then also make sure that the curve passes through the origin as it should, and our curve would look something like this. And in this last part, we want to use the equation for the area A to solve A is equal to 11,700, or what is the width when the area is 11,700? Recall the function is A equals 310x minus 2x squared. And we're just going to substitute 11,700 for A. Okay, now we're going to try to solve this graphically. We will refer to our graph of the function from part B and see when the A values, or the area, is equal to 11,700. Okay, so you can draw a line to approximate where 11,700 is, and the goal is to find the intersections. But I also want to use my calculator just if there's any error in the graph that I've drawn. Okay, so in y1, I've entered the function, in y2, 11,700, and we'll adjust our window to match the graph that we have drawn. So I let x min be 0 and x max 200. Y min is 0, Y max is 20,000. You know, that large a number was not necessary, but hopefully this will match and agree with our graph that we found earlier. And then graph. Okay, so using the intersect feature, second trace, intersect is number 5, and then just hit enter 3 times. Okay, that gives us one intersection, which is at x equals 90. And then we'll do the same step, second trace, intersect, but this time scroll to the left of the vertex and hit enter 3 times. And we see that 65 is the other x value.